Chapter 6 was verifying trig identities, some difference formulas. It was double and half angle, and then solving trig equations. So on the midterm, we're not going to be doing half angle formulas, so we don't have to worry about that. And then our double angle formulas are only going to be for triangles. So it's not going to be for a single angle. I'm going to give you a ratio, then you're going to have to make a triangle out of it. But the first one is going to be verifying trig identities. So verifying trig identities, always remember you want to change everything to sine and cosine to make it easier to work with. So first, secant is 1 over cosine. And then cosine is just cosine. And remember, we only want to work with one side of the equation at a time. So I'm going to stick to the left side. So I notice I have a fraction minus a whole number, which means I'm going to need a common denominator. So I'm going to multiply this whole fraction by cosine x. So my first fraction, which is 1 over cosine x, stays where it is. And then my second fraction becomes cosine squared x over cosine x. So now, since I have the same denominator, what I can do is I can combine it into one fraction. And now I realize if I'm looking at my right hand side, it's still not tan x and sine x here. So I have to figure out something that the top or the bottom can become. So if you notice, 1 minus cosine squared x is actually a trig or Pythagorean identity. So 1 minus cosine x is equal to sine squared x. So what I'm going to do is I'm going to replace the top with sine squared x over cosine x. And let's say you didn't know what to do from here. You can always go to the other side now. So now I see it equals tan x over sine x. So I'm going to change this side. Well, tan x is sine x over cosine x times, and then sine x is just sine x. Now when I want to multiply a fraction and a whole number, remember I put that whole number over 1 and then I multiply straight across. So I would get sine squared x over cosine x, which is exactly what I wanted, so I know it checks out. So in the rest of these, what you're going to do is change everything to cosine and sine, and then use the laws of algebra when you combine fractions, and then look for trig identities too, as in like the Pythagorean identity. Our next topic was sum and difference formulas. So we're going to use either a sum or difference formula to find the exact value of sine 105. So to find that sum or difference, remember you have to think of two numbers on your unit circle that either add or subtract to 105. So if I'm going to pick 45 and 60. So I know 105 is just 45 plus 60, and remember this formula is on your reference sheet, and it is sine A cosine B plus cosine A sine B. So I'm just going to replace A and B with 45, so this is going to be sine 45 cosine 60 plus cosine 45 sine 60. And again, where I'm getting sine and cosine from is on my reference sheet. So now I just simplify. Well, sine 45 is radical 2 over 2. Cosine 60 is 1 over 2. Cosine 45 is radical 2 over 2. And cosine 60 is radical 3 over 2. And now I just want to simplify that. So since I'm multiplying fractions, I go straight across. Radical 2 times 1 is radical 2. 2 times 2 is 4. Plus radical 2 times radical 3 is radical 6. And then 2 times 2 is 4. And then I can combine it into one single fraction because they already have their common denominator. So sine of 105, the exact value is radical 2 plus radical 6 over 4. So whenever it asks for exact value, remember there is no decimals. The next one is our double angles. So like I said, we're only going to be dealing with triangles here. So it tells us that sine A is 9 over 41 and lies in quadrant 2. So I'm going to draw this triangle. And then it says it's in quadrant 2. So sine is opposite over hypotenuse. So the opposite side is going to be 9. My hypotenuse is 41. And then remember, to find that missing side, you can do the Pythagorean theorem here. So I'm just trying to find my adjacent side, so that's going to be my A. And then my hypotenuse is my C. So this would be x squared plus 81 equals 1681. Subtract 81 on the other side. There you get x squared equals 1600. Therefore, x equals 40. So just a reminder, since we're in quadrant 2 though, my x value is going to be 0 or negative. So it's going to be negative 40 here. So now what we have to do is we have to find sine 2a, cosine 2a, and tan 2a. So I'm going to start off with sine 2a. All these formulas are on your reference sheet. So make sure you're using that reference sheet. The formula for sine 2a is 2 sine a cosine a. So all I'm going to do is I'm going to look at my triangle. Sine a is opposite over hypotenuse, so that's going to be 9 over 41. Cosine a, so remember here's your a. Cosine a is negative 40 over 41. So now what I'm going to do is multiply my fractions. So or you can plug it into your calculator. So you can just do like 2 and then in parentheses 9 over 41 and then negative 40 over 41. And that would give you an answer of negative 720 over 1681. So that's what I get for sine 2a. So now I'm going to do cosine 2a. Remember, this formula is also on your reference sheet. So that's going to be cosine squared a minus sine squared a. So my cosine in this triangle was negative 40 over 41. I have to remember to square it. My sine was 9 over 41, and I'm going to square that. So when you square a fraction, remember you square the top and the bottom. So negative 40 squared is 1600. 41 squared is 1681. Minus 9 squared is 81. And then 41 squared is 1681. Then I'm going to subtract those two fractions, and I would end up with 1519 over 1681. So that is my cosine 2a. Lastly, I need to find tangent. So this is the one formula where they give you something on the reference sheet, but remember you can use your two answers that you just found right now. So typically tan is sine over cosine. However, tan 2a is just sine 2a over cosine 2a. So remember, we just found sine 2a. It's not saying here's sine, multiply it by 2. It's your actual answer that we just found. So what we're going to do is we're going to take sine 2a, which is this answer, and then divide it by cosine 2a, which is this answer. So that would be negative 720 over 1681 divided by 1519 over 1681. So now I have a fraction divided by a fraction, which means I want to do keep, change, flip to simplify. So this is going to be negative 720 divided by 1681 times 1681 divided by 1519. So remember, you want to flip that bottom fraction. So now you can cross cancel. And then my answer is going to be negative 720 over 1519. And that's how I figure out sine 2a, cosine 2a, and then finally that was tan 2a. So you can try that with the next problem. So the last topic we did in chapter 6 was solving trig equations. So this time we have to solve for x, and x is going to be an angle on your unit circle. So here I have 2 cosine squared x minus 3 cosine x equals negative 1. So whenever I have a squared and a regular x or trig value, I want to move everything over to one side and factor. So this is going to be 2 cosine squared x minus 3 cosine x plus 1 equals 0. So when possible, remember you want all your trig values to look or be the same. So here I got cosine squared and cosine, so it's the same trig value of cosine. So since I have the same trig value, I can ignore the cosines and I can put it back in at the end. So this would be like 2x squared minus 3x plus 1. So I can factor that. You can either do borrow or pay back or split the middle. I'm going to do borrow and pay back. So I'm going to borrow this one. So it would be x squared minus 3x plus 2. And then I'm going to pay it back down here in both parentheses. So two numbers that multiply to 2 but add up to -3 would be -1 and -2. So right here I'm going to put back in my cosine because I just factored. So this would be 2 cosine x minus 1 and then 2 cosine x minus 2, and then don't forget equals 0. So don't forget to drop that down. Since I have my two parentheses, now I can tee it up or set it equal to 0. So this would be 2 cosine x minus 1 equals 0. And this is 2 cosine x minus 2 equals 0. So focusing on this one, I add 1 to the other side. I would get 2 cosine x equals 1. So cosine x equals 1/2. And on the other side, I would get 2 cosine x equals 2. Divided by 2, I would get cosine x equals 1. So I figured out what cosine x can equal, so that would be 1/2 or 1. However, I still need to figure out the angles. So during this day, we did QPA. So QPA stands for quadrant point angle. So starting with cosine x equals 1/2, it says that it's positive because there's no -1/2. It just says positive 1/2. So we're looking for where cosine is positive, and that would be in quadrants 1 and 4. Now on your unit circle, cosine is your x value, so we're looking where x is equal to 1/2. So we're looking in quadrant 1 where x is 1/2, and that would be at 60 degrees. And then we're looking in quadrant 4 where x is 1/2, and that would be 300 degrees. So that's how I figure out my two angles when cosine x equals 1/2. So let's go on to cosine x equals 1. So 1 is a positive number, so it could be in between, or it could be in quadrant 1 or 2. Sorry, 1 or 4. So remember that when cosine is a whole number, it has to be on your axes, so either your x-axis or y-axis. So if you think about your unit circle, this occurs where your angle is 0 degrees and 360. So make sure you include that 360. So overall, my x values are 0, 60, 300, and 360. And that would give you full credit if this was on the exam. So try the rest of these. The answer key is online for you to check already.